Have you ever looked up at an airplane and wondered, how does something so big and heavy stay up in the air? Airplanes are one of humanity's most incredible inventions, allowing us to travel across the world in hours. But what's really going on when a plane takes off and stays airborne? Today, let's explore the science behind flight and find out how airplanes stay in the air. To understand how airplanes fly, we need to talk about four main forces that affect them: lift, weight, thrust, and drag. These forces are constantly interacting, and it's the balance between them that allows an airplane to take off, stay in the air, and eventually land. First, let's talk about lift, the force that keeps a plane in the air. Lift is generated by the plane's wings and is created when air flows over and under them. The unique shape of an airplane wing is called an airfoil. It's designed so that the top of the wing is curved while the bottom is flatter. When the airplane moves forward, air flows faster over the top of the wing and slower underneath it. This difference in speed creates lower pressure above the wing and higher pressure below it, pushing the wing, and therefore the airplane, upward. This upward force is what we call lift. But lift alone isn't enough. For an airplane to move forward and generate lift, it needs thrust. Thrust is the force that propels the airplane forward, usually created by the engines. Whether it's a propeller or a jet engine, the engines push air backward, which in turn pushes the plane forward. It's a bit like when you push against water to swim forward, the engines push against the air, allowing the plane to accelerate. Now, while lift and thrust are helping the airplane rise and move forward, there are also forces working against it. Weight, or the force of gravity, pulls the airplane down. This is why airplanes need a strong lift force to counteract their weight and stay in the air. And then there's drag, the force that resists the airplane's motion through the air. As the plane moves forward, air pushes against it, creating resistance. To maintain speed and lift, the engines need to produce enough thrust to overcome this drag. So, for an airplane to take off, it needs to reach a speed where lift becomes greater than its weight. Once this happens, the airplane leaves the ground and begins to climb. During flight, pilots adjust the engines and the plane's angle to balance lift, weight, thrust, and drag, allowing the plane to cruise at a steady altitude. But there's more to staying in the air than just lift and thrust. Pilots also use control surfaces on the wings and tail to maneuver the airplane. These surfaces include the ailerons, rudder, and elevators, which help control the plane's direction and stability. For example, if the pilot wants to turn, they can adjust the ailerons on the wings to create more lift on one side, causing the airplane to tilt or bank in that direction. The rudder, located on the tail, controls side-to-side movement, while the elevators help the airplane climb or descend. Here's an interesting fact: even though airplanes appear to fly in a straight line, they're constantly adjusting to stay stable. Air is constantly shifting, and planes are always reacting to slight changes in wind direction, speed, and turbulence. Pilots and autopilot systems work together to make thousands of tiny adjustments throughout the flight to keep everything balanced. And while modern planes are designed for safety and stability, they wouldn't stay in the air without constant forward motion. If a plane's engine stopped, it would eventually lose speed and lift, causing it to descend. However, planes are built to glide, which means they can still stay in the air and descend gradually for a safe landing if an engine fails. To sum it up, airplanes stay in the air thanks to a careful balance of four forces: lift, weight, thrust, and drag. The unique shape of the wings generates lift, while engines provide the thrust needed to move forward. Pilots use control surfaces to keep the plane stable and navigate through the air, ensuring a smooth and safe journey. So, the next time you're on a flight or see an airplane overhead, you'll know there's some incredible science at work keeping that massive machine in the sky. If you enjoyed learning about how airplanes fly, hit that subscribe button for more science explainers. And tell us in the comments, what other amazing science